Hello everyone, the Humble Math Tutor here. Today we're going to work with negative exponents. And there's a power rule for that. A to the negative n is 1 over a to the n. For special circumstances, there are two variations on this rule that might be helpful. If you find yourself with a negative exponent in the denominator, you could use this. 1 over a to the negative n is a to the n, and if your base is a fraction, you can use this. A over b to the negative n is equal to b over a to the positive n. Now, in another of my videos, I discuss these in detail. I derive them, justify them, and explain them. But in this video, I'm just going to use these rules to simplify some questions. Here we go. Simplify 4 to the negative 2. Now compare this question with the left-hand side of our first power rule here. It's as if a takes on the value 4 and b and n takes on the value of 2. So this would become, check out the right-hand side, 1 over 4 squared. And of course 4 squared is 16, so I write 1 over 16 as a final answer. How about pi to the negative 1? Yes, pi can be a base, no problem. So in this case, a takes on the role of pi and n takes on the role of the 1. And you would have 1 over pi to the 1, but nobody uses 1 as an exponent, so we would just write 1 over pi. How about this question? Negative 5 to the negative 4. The brackets ensure that the negative 4 exponent applies to this entire base, negative sign included. So you would write that as 1 over negative 5 to the positive 4. Now for clarity, I'm going to write that negative 5 4 times on the next line, and that would be negative 5 times negative 5 times negative 5 times negative 5. If you multiply that out, you're going to get 5 times 5 times 5 times 5 is 625, but I also have an even number of negative signs. The answer will become positive. By way of interesting contrast, look at this question. What if I had negative 5 to the negative 4? In this case, the negative 4 exponent applies only to the 5. The negative sign out front waits to be administered last. Think order of operations, exponents before subtraction. This would be the negative of 1 over 5 to the positive 4. And then, as we've seen in the last question, 5 to the 4th is 625. And that would be your answer. So this time we got a negative answer. So that contrast between the last two examples is a very important one. How about this question? 2 times 3 to the negative 4. Again, think order of operations. You must execute an exponent before multiplication, but you must keep track of the multiplication which is pending anyway. You have to write 2 times in front. And this is converted according to the power rule, 1 over 3 to the 4. Multiply 3 times itself 4 times and you get 2 times 1 over 81. There is, of course, an invisible 1 underneath the 2. You can multiply out the tops and the bottoms, and that gives you 2 over 81 would be your final answer. Remember, with these questions, you can pause them at the start, try the question yourself, see how successful you are, then come back, resume the video, and check to see how your answer went. All right, let's try the next question. In the next question, what I'd like to do is write this expression with positive exponents. Well, the x already has a positive exponent. It's only y which is lumbered with a negative exponent. So we'll write this down as x squared unchanged, but the y cubed becomes 1 over y cubed. Now there's an invisible 1 underneath the x squared, and again we multiply out the tops, multiply out the bottoms, and that would give us x squared over y cubed. With some practice, you'll get used to going from the first line to the third line. What you'll do is you'll view it like this. You'll say, this y has a negative exponent. I'm just going to move it underneath the x squared and give it a positive exponent. And you won't bother writing this out. All right, next example. Simplify this. M to the negative 4 over m to the negative 3. This looks like a case of dividing powers with like base. And you know that's power rule number 2. You're supposed to subtract the exponents when you do that. So that would be m to the negative 4 minus negative 3. That's a double negative. So I should change that to a positive. M to the negative 4 plus 3. Adding those numbers up, I get m to the negative 1. And that's going to be just simply 1 over m to the 1. Nobody uses 1 as an exponent. They would write it as 1 over m. Very good. In the next set of examples, we're going to explore the middle of the 3 power rule variations we're working with today. So that is this one. 1 over a to the negative n is a to the positive n. Let's look at some examples which help us understand this variation of the negative exponent power rule. Let's start with this question. 1 over 6 to the negative 1. View the structure here. It's identical to the structure here. A takes on the role of 6 and n takes on the role of 1. And that would give you, for an answer, 6 to the positive 1 in a heartbeat. It's a very efficient rule. It's really a good way to avoid lots of unnecessary extra steps. Let's try this question next. 1 over e to the negative 10. So you do it the same way. I'll try to keep this power rule in the picture as long as possible. And this would become simply e to the positive 10. It's that fast. Let's complicate it slightly now, just a little bit. How about if we are required to simplify this expression? 1 over 4x to the negative 2. In this case, the 4 already has a positive exponent. We can't really go moving it around. We should just leave it alone. In this case, I have x to the negative 2. The negative 2 applies only to the x. I'll just move it up top and give it a positive exponent. Fast and efficient. This would simply become, in one line alone, x squared divided by 4. Very efficient. How about this one, where we have 1 over x plus y to the negative 1. No problem. You just take this base, even though it's a binomial, and you write it in the numerator position with a positive version of that exponent. And that would give you x plus y to the positive 1. Nobody uses 1 as an exponent. You just write x plus y as your answer to that question. Very good. No problems, no worries. On to the third of our 3 power rule variations for negative exponents we're working on today. Let's try this question. Getting my page lined up. 2 over 3 to the negative 3. Now remember the power rule we're working with. The third of the 3 types I talked about today read like this. A over b to the negative n is b over a to the positive n. Please excuse me. That's just an n here. Now, in words, describing what we see here in words, we flip the numerator and denominator and change this to a positive version. So we're going to flip the numerator and denominator and change this to a positive version. And that gives us 3 over 2 to the positive 3. I'm going to cube that out. So that's 3 over 2 times 3 over 2 times 3 over 2. Multiply out your tops. 3 times 3 times 3 is 27. 2 times 2 times 2 is 8. Leave that in improper form. Alrighty, well done so far. That's just great. Try this question with letters. That's c over 2d all to the negative 2. In this case, We're going to reverse the numerator and denominator, even if they look a little difficult or awkward, or they look algebraic, or they've got letters. Doesn't matter. You still put this on the bottom, put this on the top, and change this to a positive. That's going to give us 2d over c to the positive 2. And I'm going to actually write that out. I'm going to square that out. 2d over c times 2d over c, because you're squaring it, so you're multiplying it by itself. And that's going to give us 2 times 2 is 4. D times d is d squared. That's 4d squared. And c times c is c squared. Very good. Thank you very much. If you enjoyed this video, please like, subscribe, and share. If you have suggestions for topics you'd like to see covered in future videos, please leave them in the comments below. Thank you.